Good morning. This is the notes for pre-calculus for Friday, November the 3rd. We are looking at first this worksheet. This is the worksheet we've been working on in class, the notes for solving exponential and logarithmic equations, and you got these notes on Wednesday. We're going to work on 1 through 10, starting with 1 down here at the bottom, these 5, and the 6 through 10 on the back, okay? So our learning target is still, I can solve exponential and logarithmic equations. Remember, how do you know something's an exponential equation? There is a variable in the exponent spot. So let's look here at this first one. Remember, there's two strategies to solve an exponential. The first thing you try is you see if you can get the bases to be the same. Can you take a moment to look at this? Can we get the bases the same? No. So we must take the log. Use the second strategy in which you take the log of both sides. The power rule allows you to bring the 2x down. Take the natural log of this side, left side, and the natural log of the right side. We already discussed that the natural log of e is equal to 1, so we don't have to worry about that. 2x equals the natural log of 20. You can just divide by 2. So in your calculator you can do natural log of natural log of 20. Like that. Close your parentheses like that. And then divide by 2. And you get 1.4979 as your answer. Okay? Let's look at number 2. Log base 3 of 2 minus x equals 3. First thing, this is our logarithmic equation. You know that by the word log is in the problem. Now you have two strategies for logs. Okay? I'm going to write these up here. Exponential same basis. Take log of both sides. Logarithmic put in exponential form if there's one log, only one log present in the problem, or you can use your properties. Use your properties. Okay, there's only one log in this problem, so I can use this first toolkit strategy, put in exponential form. So we got that exponential. 3 cubed equals 2 minus x. 3 cubed is 27 equals 2 minus x. Divide by that negative 1, and negative 25 equals x. Number 3. 16 raised to x plus 3 equals 4 raised to 4x plus 7. This is exponential. Variables are in the exponents. First thing I'll try is get the same basis. Well, I can get the same base here. They can be both base 4. So I'm going to write this as 4 squared, because 4 squared is 16. That's power to power, so you're going to multiply it 2 times x plus 3. Now that I have these bases the same, I can typically ignore those and just say 2 times x plus 3 equals 4x plus 7. So Mr. Fisher, what if I went ahead and multiplied that in my head and got 2x plus 6? That's fine. and you get negative 1/2. If you need to stop and pause the video right now and look at it, then you may at this time. Alright, number 4. Log base 7 of x minus 6 minus log base 7 of x plus 5 equals 1. Okay? This is logarithmic because you see the logs in there. And if you look back at our toolkit strategies, you can put an if there's only one log, but there's multiple logs here, so we can't do that. So we need to use our properties to condense. Well, I see there's a minus there. That's the quotient rule. So I'm going to condense it to 1 log x minus 6 over the x plus 5 equals 1. Now, since I have one log, I can write an exponential form. 7 to the first equals x minus 6 over x plus 5. 7 to the first is 7. Now I can cross multiply. 7 times x plus 5 equals x minus 6. X equals negative 41 over 6. Alright, let's look at number 5. Log base 5 of x plus log base 5 of x plus 1 equals log base 5 of 20. Alright, your properties. Put an exponential form if there's only one log. Well, there's multiple logs, so you can't. There's multiple logs here, so you can't do that. The second one is use the properties. Now, I want you to notice the difference between number 4 and number 5. Number 4 didn't have a log over here. Okay? But in this one, all 3 of them do, so you can drop those and just use your rules. That's plus, so it's part of the rule. X times x plus 1 equals 20. We can drop the log base 5 because it's the same throughout. Every term has that. Now distribute x squared plus x equals 20. It is quadratic now. Gotta get it equal to 0. So that gives me x plus 5, x minus 4. That gives me x equals negative 5 and x equals 4. When you get more than one answer, you have to check. If I have negative 5, I have to throw a negative 5 in. That's a negative sitting next to that log. Remember, logs are not defined for negative, so that is not your answer. You only have one answer, x equals 4. Okay. Let's look at number 6. 6 plus 2 log, that's understood base 10 of 5x equals 18. Okay, this is logarithmic. So step 1, you see if you only have one log. I do, so I'm going to put an exponential. But before I do that, guys, I have to get the log isolated. So I'll move the 6 over as a negative 6. Then I'm going to divide both sides by that 2. Now that my log is by itself, I have 1, I can put an exponential. It's an understood base 10. 10 to the 6 equals 5x. So it's going to be 1 million equals 5x divided by 5 gives you 200,000. Number 7. 8 raised to x plus 2 equals 32 raised to 3x. This is an exponential equation. You know that because your variables are in the exponent, hence the name exponential. Now, your first line of defense is to get the same base. I want you to take a moment to think, what base could I make 8 and 32 in the same base? Okay, I hope you said yes, because I can rewrite this as 2 raised to the 3rd. This can be written as 2 to the 5th. So now that I got my bases same, I can ignore those and just rewrite 3 times x plus 2 equals 5 times 3x. Distribute 3x plus 6 equals 15x. Divide by 12 and 1/2 is my answer. Number 8. 36 raised to x plus 1 equals 6 raised to x plus 6. You look there for a moment. You notice that it's exponential. First line of defense, can you get the base same? And yes, you can rewrite this as 6 squared. So it's 6 to 6 to the 2nd. Okay, the bases are the same now. You can bring the exponents down. 2x plus 2 equals x plus 6. X equals 4. X equals 4. Alright, we are dealing with a logarithmic because you see the natural log. So your first line of defense is, do I have one log? If I do, then put it in exponential, and I do. But before you can put this in exponential, you need to isolate. That means get the ln x natural log by itself. So I'm going to divide both sides by negative 3. Natural log of x equals 8. Now that this is isolated, you can put it in exponential form. Understood base is e, that's the only base you have in natural log. E raised to the 8 equals x. Well, then I'm going to put that in my calculator. So second, put 8, and I'm going to do 4 decimal places. So it'll be 2,980.9580. The 8 rounds to 79 up. So x equals 2980.9580. Alright, and our last one, number 10. E to the 2x minus e, that's supposed to be the x, equals 0. That's supposed to be to the x. Sorry about that typo on the thing. We talked about these today. This is exponential because you have the variables are in the exponent spot, but it's also very similar to a quadratic. So when you have that, it has to be set equal to 0, and you use what's called U substitution. You're going to let U equal that the e, the middle part, e to the x. Now you're going to substitute u in. U squared minus u minus 2 equals 0. Factor it. That's the u minus 2 and u plus 1. Now substitute e to the x back in. E to the x minus 2 equals 0. E to the x plus 1 equals 0. Solve the equation. Okay, this is exponential. Can't get the bases to be the same, so I got to take the log of both sides. Take the log of both sides. I'm bringing the x down. Natural log of e equals natural log of 2. Well, we know that natural log of e is equal to what? 1, correct. X equals natural log of 2, which is 0.6931. Now, we're going to solve this one. We learned today that if this is set to a negative value, if we went to do this, watch this, x natural log e equals natural log negative 1. Natural logs are not defined for that negative value when it's sitting next to this. It's not. So this cannot work. Cannot work. So your only answer is right there. Because if you have natural log next to negative 1, negative value will not work. Just like if there's negative value next to a log. So, on Friday, after we went up going over these, we're going to work on number 11 through 20 on this worksheet. Starting at number 11 and going through 20, doing the same practice. All of this, 1 through 20, should be completed by Monday. Thank you.